12 million light-years away in the southern sky lies a giant. A galaxy of fire and dust known to science as Centaurus A. At its heart sits a monster, a supermassive black hole with the mass of 55 million suns. For eons, it was a silent gravity well, a predictable cosmic engine consuming everything that drew too near. But recently, something happened that shouldn't be possible. The black hole emitted a terrifying, ultra-bright glow, a flash as if trillions of lightning bolts had struck the exact same point in space. It was a signal that wasn't just loud. It was a warning that our understanding of the universe might be fundamentally broken. This incredible signal was captured by the High-Energy Stereoscopic System, or HESS, an array of telescopes located in the stark beauty of Namibia. Under a brilliant Milky Way, their massive mirrors are angled toward the southern horizon, designed to see the invisible, the most violent and energetic gamma rays in the cosmos. These are the spectral fingerprints of cosmic cataclysms, and what they recorded from Centaurus A was unlike anything seen before. In the data, a graph that should have been a flat line of quiet background radiation suddenly spiked into a jagged mountain of energy, then vanished just as quickly. Normally, supermassive black holes are predictable beasts. They consume surrounding matter, and as this material spirals into the accretion disk, it heats up and emits steady jets of radiation. Predictable physics governs this process. But the behavior observed from Centaurus A didn't fit this model. The flare of energy wasn't from the predictable jets. It came from the event horizon itself, the absolute point of no return. It was a terrifying glow composed of high-energy gamma rays, generated so fast and with such immense power that it defies every existing model of astrophysics. According to Einstein's general relativity, a black hole is a perfect trap. It's a region of spacetime so warped that nothing, not even light, can escape once it crosses the event horizon. But the beacon from Centaurus A acted like a light bulb that had suddenly and violently short-circuited, shattering that very concept. To create a flash this bright, particles would have to be accelerated to near the speed of light within a tiny, incredibly concentrated space right at the edge of the black hole. Current science tells us that the magnetic fields near a black hole, powerful as they are, shouldn't be capable of this feat. It was as if something fundamental inside the physics of the black hole had snapped, revealing the workings of a new type of celestial engine, one that science to this day cannot explain. We are witnessing a singularity shift. What could possibly cause such a tremor in the fabric of spacetime? The flare has forced astronomers and physicists back to the drawing board, erasing old certainties and opening doors to radical new ideas. Some researchers now speculatively suggest we are seeing the birth of a singularity shift, a moment where the internal structure of the black hole reacts in a way we've never witnessed, a fundamental change in its state. Could this be the long-theorized but never observed signal from a white hole? A hypothetical cosmic object that spews matter out instead of drawing it in? Or perhaps it is evidence of matter being shredded and annihilated at a level beyond the subatomic, releasing energy in a process unknown to us. We are listening to a voice from the abyss, but we don't yet speak the language. Centaurus A has fallen silent again, returning to its dark, brooding state, a quiet monster in the distant cosmos. But the signal remains in our data, a ghost in the machine of the universe, a permanent record of an impossible event. We thought we had mapped the laws of the universe with our equations and theories, confident in our understanding. But the terrifying glow of Centaurus A reminds us of a humbling truth. The deeper we look into the dark, the more we realize. The light still has secrets,